So, so what is the technology that we'll be using for PubSub here then?
Yeah, good question. So I'm thinking of something where we can actually maintain the order, right? Now, given that it's a very latency sensitive system, uh, it looks like we cannot use systems like Kafka or even the older systems like RabbitMQ or anything, right? So, so maybe we need to build something in-house, right? Uh, where the whole PubSub system will be operating out of memory so that we don't need to put uh, everything to disk, while publishing is actually going on every time. Uh, I mean, we have to actually minimize that. But now the next question actually comes is like, let's say if this whole PubSub is in memory and we have developed something in memory, we are not using anything uh, known or open source. Then how will we actually store the events, right? Uh, let's say if the system crashes, if the PubSub itself actually crashes as an example, right? How will you actually get the events? So what do you think? I mean, if let's say that we have in-house PubSub, which is in memory, right? Uh,
So
but
you mean basically our current storage system is basically in memory. So everything is we are storing in memory right now.
yeah,
So how do we, ensure the availability now? Because let's say if our server goes down, then we actually lose whatever was there in the memory. So how do we ensure the availability in that case?
yeah. So since the latency is a big concern here, one option is that see this PubSub is also kind of a library, right? I mean, it's essentially a library only, right? So it can take the messages, uh, but it has to have some way to actually just persist the message very fast, right? So that we don't lose the events at all, right? So every time we publish something to the PubSub, uh, there are a couple of options maybe I can think of. Maybe one option is that we directly use some DB, let's say. We directly use some DB where the PubSub is actually going to dump the data into the DB. But again, the problem is that what is the latency coming from the DB, right? Even if it is in the same machine, what is the latency coming from the DB while dumping? That is something which actually needs to be checked, or whether the DB can actually scale for millions or billions of events that we are actually going to get on a daily trading day basis, right? So that is something which has to be checked. Maybe another option could be something like whenever the PubSub system is getting any message, before actually publishing before publishing the event, it simply dumps the data into some WAL kind of log, WAL log, like whenever we actually um, do some query to some database, right? First of all, it actually puts the data into the WAL log, and then actually the actual execution goes ahead, right? So what about actually using a WAL log here, right? Where we just simply dump the data. We don't do any processing. We just simply dump the data and go ahead with publishing internally, right? So I think in that way, even if the machine crashes, right, the data will be there in the hard disk. And I assume that in these kind of big machines, there are multiple hard disks or RAID disks that actually you can use, right? So you can easily take this disk and connect it to maybe another computer, just as a failure recovery mechanism, right? So maybe every time the PubSub system gets some message, every time we can dump it to the disk sequentially. And assuming it's an SSD, it will be faster, right? Or there may be one more option to maybe batch the message into the PubSub system. And let's say every 2 seconds or every 5 seconds or some frequency, we dump the batch into the disk so that the sequential write is also faster comparatively, right? So that has to be also definitely, uh, I mean, tested and we need to find out what is the actual latency that actually comes there. But that comes with a little bit of trade-off that while the batch is being generated, it's still in memory. And if the machine crashes, we'll most likely lose that data at that point in time, right? That's one trade-off there.
Yeah.
So do you have any
Yeah.
other
So
thoughts
that
here?
kind of defeats the purpose of val any. I mean, if we lose the data even before val, then basically that defeats the purpose of val. So I think it's better to just write every single order as soon as we get into the system. But yeah, there is one
Yeah.
more thing here. So since we are writing into disk, and disk basically takes some time to write. I mean, a single disk C can take up to 10 milliseconds,
Mm.
and there is also limit to how much data can we write per second in the disk. So I mean, so the thing is, if this seek is like taking 10 milliseconds, and let's say uh, I'll assume that it takes 1 to 2 milliseconds for the write. So our initial assumption, I mean, goal for overall latency was 20 milliseconds. So basically half of the latency that we have just eaten here only. So what do you think? I mean,
Yeah, so that's what I'm saying, that first of all, you are probably talking about hard disk. We need to actually see what is the disk seek for SSD. There is no disk seek in SSD, by the way. I think there is no disk seek in SSD at all, right?
okay,
It's some different kind of mechanism how data is written. Disk seek is only there for HDD or magnetic hard drive. So since we are not using magnetic hard drive in this big machine, I don't think so we should think about disk seek,
Mhm.
right? So in that way, we still need to see the latency, but I think it's a single digit latency, maybe 3-4 milliseconds or something like that, right? I mean, we still need to check that,
Yeah.
right?
So
So,
also, we are actually writing all the orders sequentially. So for sequential
mm,
orders, I mean, there won't be much disk seek, because disk doesn't have to rotate and look to a particular location, because it's actually writing sequentially. So there
mm,
will be disk seeks, but they will be very they won't be that frequent. So on average, I think the overall latency will still be like it'll be much less than 10 milliseconds for, I mean, if we
yeah,
take an average for one order. Yeah.
yeah, uh,
Okay. So
yeah,
I
maybe.
think,
I mean, it's still subject to our testing. Let's say you're designing the system in a
yeah,
real life. We need to make some tests
yeah.
there to actually see what actually works there. But that is the approach probably that we can take, right? Okay.
Mhm.
So now, let's say that so if the machine crashes, one of the option is that uh, do we have another machine where you can connect to this disk? But is that a realistic way to do this? Right? Let's say this whole big machine crashes for some electrical issue, right? We have another machine backup. Now that machine has to read the events from the disk. Now, is that actually going to be fast? Is the question, right? Or is there any other way uh, so that that machine can actually remain in standby mode and still getting the messages and not doing anything? You're getting the point, right? I mean, putting data into disk is one thing,
Yeah,
and keeping some machine as a standby mode and getting the data but not
mm,
acting on them is a different thing, right? I mean,
yeah,
since both of them will be co-located in the same region or in the even in the same location, or maybe yeah, in the same location, uh, definitely there is a chance that the whole data center burns, but the chance is very less. But it can still happen, right? So there might be some
yeah. Then
asynchronous.
the stock exchange will die anyway, so that's
Yeah.
okay actually. I mean, we have, I
Okay.
mean, to basically ensure the availability, in that case we will basically need another data center, and we cannot have another data center in case of stock exchange anyway. So maybe
I mean,
that part we can rule out.
we might have just as a backup. I mean, there has to be some level of backup into maybe some other data center. Just that the failover will actually take some time, right? I mean, we won't be actively communicating, or we won't be putting it in the right way. We won't be communicating with the data center in our critical path, right? But there will be still some backup going on, right? Asynchronously from the behind, from the background, so that even if this exchange dies or this data center is burned, we can still fail over, let's say DNS fail over to the other data center, maybe in just few minutes. You're getting the point, right? So it won't be on the critical part, but the
Yeah,
backup should be there, right? So the same thing can be there as a redundant. We can put a redundant machine into the same data center, and we can definitely connect the disks. But I think that's a little time-consuming process, right? So maybe, what do you think? Can we publish the PubSub data to some port, and the other machine's PubSub can actually listen to this port and can, let's say, take the data. Is it an option?
So one more thing I think that we can do is basically, so we know that, our system is basically built in such a way that, if we apply the same sequence of orders at a particular time, then it will basically give us the same output. So
Hmm.
what we can do is basically we can have a standby machine, which is also doing the same things basically. So it also has a pub sub inside, and
Yeah.
it's also basically getting a copy of the same orders. So at a particular time, it also has the same state. So for example, at let's say 12 o'clock, I had two orders which were matched. So both of these systems will have basically the same state at a particular time. But that machine's data and output is not being used anywhere. So, I mean, it basically it's doing all the things. It also has the same state, but we're not using that.
Yeah. Yeah, we're
So
doing that.
this
But the
machine
point
dies,
is,
just redirect the traffic to that.
but the
Yeah.
point is, how is that machine getting the data? So that machine pops up, or the message bus system also should get the data. So is it getting through some data publishing or data broadcasting, something like that? Uh,
We can
that
make
machine
it
has,
read the val, I mean, write a log.
no, no. I mean, you mean that both of the machines will be reading the same disks or using the same disks? Is it possible? I mean, I don't know. I don't have that hardware idea.
Oh, sorry.
These are in different
Uh,
hardwares, right? This is, I don't know if the shared
yeah, I
hardware is
mean,
possible or not.
I don't think that can be done. Yeah, yeah, yeah.
I mean, I
I
don't
mean,
I
we'll
don't have
have to
much idea about
basically
it.
ship
Yeah.
that log.
I mean, it's
Yeah.
like kind of
So,
replication, but whether it's kind of a replication problem only in the same data center, right?
yeah,
But
yeah,
whether the
yeah, yeah,
replication
yeah, yeah.
has to be orchestrated by this PubSub system, right? Like database replication happens, or the data can be simply published to some port, and is it reliable? That if we publish this data to some port and the other machine actually listens to this port on this machine, will it be able to get the data, right? Or it should be like proper
So
replication where
basically, I mean,
it like,
uh, so most of the I mean, databases like Postgres, they actually, for replication, what they do is basically they ship their, write ahead logs. So the other machine will, get those logs. How do they, ship those logs? That is basically their own protocol. Basically, the idea here is the other machine basically gets the same logs. I mean, it replicates those logs in its own system, and then it basically applies those in its database. So I think we can do the same thing. So it's ultimately just copying
okay.
the write ahead log to another machine, and then that machine basically reads those logs and
Yeah,
applies them.
maybe the other machine can asynchronously copy these logs through some, yeah,
Yeah,
through some port or through some API, or something has to be there, right? Not API, I think, through something, right?
yeah, yeah,
Asynchronously,
yeah. So we can, yeah,
which will not be interfering
yeah.
with
There
the
can be some
critical
daemon
path.
running on this machine, which basically listens to
Yeah,
the requests, copying
true.
requests.
Okay, okay, makes sense. Okay, we need to discuss how the order matcher maintains the data of the symbols, like how it is the buy volume,
Mhm.
what is the sale volume, at what price. But before that, you have anything else in your mind? I mean,
I think let's go to the. I mean,
yeah, I think one thing, let's discuss
that
reporting system.
anyways. I think.
Yeah, before we move on to that,
Okay.
so do you have any idea about how do you actually publish the reporting data? Because there will be multiple brokers who will be needing this reporting data, right? So
Mhm.
do you have anything in mind how this reporting data can be published to
So,
external systems?
so if we basically, take this system to a normal real life system. So let's say I have this system which is basically where the some data is continuously being updated, and there is another system which basically has to listen to this data. So one
Mhm.
simple approach is basically it provides a REST API. and the other listener system basically posts this API continuously, maybe at 1 second, 5 second, or at any second. But the problem with this approach is that if the price is not fluctuating that much, so let's say it changes after, let's say, 10 minutes, then a lot of calls will be basically wasted in between. And there may be certain stocks, I mean, whose prices fluctuates a lot, and then there would be other stocks where the price fluctuation is not that much. So that's why we cannot basically determine basically, I would say, a global common polling period. So I
I
mean,
think
at which
price.
all the
I,
stock.
I think we
Yeah.
can expect price fluctuation actually, because in the end of the day, the system is going to probably support thousands of symbols, right? So some price fluctuation will be anyway there, whether it's a one or thousand or maybe 100,000. Some activity is going to be there anyway, right? So we can actually assume.
No. Price fluctuation is happening. I'm saying that the price fluctuation might not be same for all the stocks. So for some
Ah, I
stocks, the
see.
price
Okay.
fluctuation might be a lot. For others, it might not be that much.
Hmm.
So we cannot determine a global common polling period at which everyone should poll. So that is one problem with that, and a lot of calls will be wasted in between. And yeah, so that is basically the problem with polling. So I mean, to avoid that, obviously, the other technology that should come to your mind is basically WebSocket. So we make a WebSocket connection between the stock exchange and the broker, and whenever the price changes, basically the exchange pushes the price change notification to the broker, and the broker basically updates on their end. But the problem with this system is basically, it's a sockets are basically two-way communication. So they are basically used when the broker should also send the data to the exchange, which is basically not required here. So if we I mean,
And also you need to
when
maintain
some
the connections probably, if you are doing WebSocket,
connections
you need to
also you
maintain
need
the
to
connections.
maintain. Yeah.
Yeah. That's
Yeah.
not
So a
required here actually.
better way of doing, yeah. So something, I mean, better technology in this case would be basically server sent events. So server sent events is basically, the broker. Yeah. So basically what happens is, the client makes an API call to the server, and server sends a response, and in the response, basically it sends a header, keep alive. So which basically means that browser should
Hmm.
keep the connection alive. So, and then through that connection, server actually keeps sending the events to the client. So it's like a socket only. I mean, there is persistent connection between the server and the client, but client cannot send anything through that connection to the server. So if client wants to send anything to the server, then it has to make a separate HTTP call. It cannot do in the same connection. So this
So how
approach is
does the
actually,
so
yeah,
how does the server know which connection or which port to actually publish the data to? Do you need to write any
which
logic for
port?
that? Yeah. So you said that clients are connected to this brokers are, let's say, connected to this system, and
Yeah.
SSE connection is keep alive connection is open, right? With some key connection is open with some keep alive value, right? And now this pops up, process has to know that, hey, I have to publish connection, I have to publish data to these connections or to this list of connections. So
Mhm.
how does it actually happen? Is it like some framework has to be there, or how does it know
Yeah, yeah.
which connections are SSE connections?
So, I mean, I know that, in Play Server, we have this framework called ECKA,
Okay.
AKKA. And
Mm-hmm.
ECKA is, I think, not, I mean, it's basically a library, and not just Play, it can actually be used in Java as well. I think
Mm-hmm.
it can be used in Spring as well. So, ECKA actually provides a nice framework for these kind of things. So, for every single connection, it actually makes an object in the memory that the code can use. So let's say I created an object. Let me call it maybe uh, I actually forgot. I think it was yeah. I'm not able to recall what I mean. What was the
That's
name of
okay.
the object?
That's okay.
Let's say
Mm-hmm.
just call it connection. Yeah.
Mm-hmm.
So these connection will be stored in the memory of the server, and they will basically so all of these objects also have a listener. So they have a, I mean, basically when you are writing the object, I mean, when you are writing the implementation of that object, if there will be a function that you have to write, which is basically on message received or something like that. So it's basically like a callback. So whenever there is whenever we basically want to send something to the connection, we actually make a call. We basically call the on message received function of that particular object. So and they can be basically, so what you can do is, since they are objects, so you can just assign some random IDs to all these objects, and you can save in your RAM. So let's say I created a hash map of all the connections that which are connected to this particular server. So
Mm-hmm.
the connection object has been given by the akka.
Mm-hmm.
And now what I'm doing is basically I'm creating a hash map where I have one one is basically my ID, which is basically connected to the connection object. Let's say my first connection, so something like that. So whenever you want to find some, you want to send something to the connection, you go to the hash map, you find the connection object for that particular ID, and then you send the
Mm-hmm.
message to that. So it basically works something like that. So I think on the ground level, whenever there is a new connection, basically, coming to the server, it on the basic level, it actually opens a new port, and it also does some connection multiplexing, which I'm not pretty sure how it works.
Okay.
But yeah, so it basically on the very basic level, I mean, for every single connection, it opens one port. So yeah, it basically works something like
So
that.
so here for this problem, right? The pricing engine, whatever we are calling here, or maybe you
Yeah,
should actually better call it, maybe price, price ticking
broadcast.
basically. I don't know. I mean,
Uh,
price ticker, something like that, right? It
yeah, yeah.
essentially has all the current price value for different symbols. So that
Mhm.
also has to be broadcasted, right? Now the point is,
Yeah.
okay, instead of using all this framework and all this SSE and everything, right? Do you think so? So we have very pretty old exchanges. I'm not sure whether these exchanges actually use this kind of framework. So is it possible to actually publish this data through some level of port publishing, UDP publishing, multicast, or something like that? Is it doable? Whether it's a
So
price taking
there
data
is,
or reporting system, because that's a little less overhead, right, for this exchange to do.
yeah, yeah. So I think there is something called UDP multicast. So I mean, it's basically the underlying protocol is UDP only. So there won't be any ordering between the packets. But what
Mm.
you can do is basically you can pack the price of a particular stock. I mean, the current price of the particular stock, put that in the packet, and then you can basically sort of broadcast that packet to all the brokers who are listening to you. So the brokers can basically register themselves in the multicast, and our price ticker can basically broadcast through the UDP multicast system or
Yeah, through
protocol,
the
whatever
port,
you call it.
basically, you are saying. Yeah, so essentially,
Yeah,
the
yeah,
external systems, they have to listen to this particular port. Right
yeah.
now, I'm not 100% sure actually how this whole mechanism actually works.
Mm.
But this looks something like doable. Maybe we need to read up a little bit on this, basically how this multicast or broadcasting thing actually works, right? But looks like there has to
Yeah,
be some specific port on this exchange server, and from different subnets, as you explained, brokers can listen to this particular port and get the data. And for price ticker, definitely UDP works. I mean, even if you miss some price ticking data, who the hell cares? Nothing will happen, right? Maybe for reporting system also it works, but I would still say for reporting system, maybe API looks like a good option. Uh, or maybe, as you said, SSE looks like a good option because we don't want to miss any data from the reporting system, right?
yeah,
So yeah, from those two, we need to see basically which one looks good. Maybe API. I think API also works, even if let's say there is no update, no data updation, right? Maybe the client is going to get old data, but the likelihood of
yeah.
that is actually very less, right? And the
Yeah,
client can
we can
actually
enforce
specify.
some strict. Yeah, I mean, we can enforce some strict rate limiting here, so that people don't abuse this system, and we can just go ahead with a simple HTTP.
Yeah, and maybe I'm
Okay.
thinking that this reporting system can have some database because it's not in critical
Yeah,
path
yeah,
anyway,
it should have some
right?
database.
So yeah, so this is the reporting database, right? So given the time stamp from and to, it can actually fetch the data, right? So I think that should be doable here, right?
Yeah.
Okay. Okay. Anyway, so this is integrated to this. Fine. Okay. Okay. Coming back to the other order matcher, I think one thing we haven't yet discussed is essentially like how the data is going to look like for the order matcher, right? So there is, if you see here, there are two portions, right? One is essentially buy, another is sell, right? So
Mhm.
let's say this is buy area, and this is sell. Man, how do I write it here? Okay, I can't write it here.
Double
Okay,
click, I think.
no, double click comes here only. Okay, anyway, the first one is basically buy, right? And the second one is basically sell, right? So this is kind of you can say like let's say that we have some okay, let's delete this figure, man. Let's put it here, right? Let's put it here. Let's put this buy here, and let's put this sell here, right? So now what happens is that let's say that for some buy price, let's say 100, sorry, 100, 10, okay, let's say 10.01. This is a buy price, right? And currently someone, okay, let's do it for selling. It will be easier to understand, right? Yeah, let's delete it from here. So for the sale, right, for certain price, there will be certain allotments. Let's say I have sold, uh, say 100 shares, right, at a price of 10.01. So I can have a list of, I can have kind of a key value pair where the price is actually pointing to the volumes that I have, right? And next lot comes something like someone has sold at the same price 200. And in a similar way, someone has, the price is increased now, and someone has now
Uh,
sold
so
50.
is it
Yeah.
sold or trying to sell?
Yeah. So basically, when you sell, right, the matcher
Mhm.
first puts this data in its own data structure, let's say internally, that it has these sale volumes, it has these sale things, right? And whenever you are actually trying to, so basically, the selling happens virtually when the order matcher has actually accepted the selling, right? Irrespective of
Yeah,
their matching or not, irrespective of their matching or
yeah,
not. If you
right.
remember from our first discussion, is that probably we are going to hold this data for one day, and if for some reason the selling has not happened, we'll return it back, right, to the party. So this data, it's not only 100 200, it also contains who is the seller, right, what is the transaction ID and what not, different
Yeah.
other metadata basically. So it's kind of an object that you're actually going to have, but for simplicity I've just wrote it, I've just written it like that. So the selling data structure contains at what price, how many volumes got sold, and from which so from which user and etc. For which broker, client ID, etc. Similarly, whenever buying is going to happen, right? Let's say that someone is trying to buy it, 9 point, let's say 99 price, right? And let's say 70 is the volume that someone actually wants to buy. So the matching system puts it into its own data structure, and now it's actually try to see, okay, fine, how now there can be different matching algorithm. So what best the matcher can do here? Either it can try to find out if uh, someone is already selling at 9.99 price, or if not, what is the nearest, what is the nearest selling price, right? So it can come and you can see that, okay, fine, it has probably available from 10.01. I mean, at 10.01, there are some lots available from some user, and then it actually tries to match it, right? Now there might be some threshold, right? Let's say 9.99 and 10.01. There is some difference, there is some delta, right? And depending on the volume, it might happen that the delta becomes bigger and it might not please the user who is actually buying this order. You're getting the point, right? So there might be some level of threshold in the user agreement which tells that probably in this threshold the user is happy to actually buy this order, buy this lot, or those kind of things can be configurable in the algorithm, right? So eventually the point is that we want to figure out if we have volumes available at this price or at a very nearest price within certain threshold. This is just one of the easiest algorithms that we are actually describing here, right? So when it happens, we just allocate, let's say 70 from this list, I mean from this user to this guy, and we pass an event that, okay, fine, this selling is successful or this matching is successful essentially. This is the buyer details, this is the selling details, and those things will be eventually passed on to the reporting system, right? And accordingly, this list will be also updated to like remaining is now 30 for this particular user, right? In a similar way, I mean, the selling can happen like if there is not enough volume available in 10.01, right? It can then see whether 10.03 comes under the threshold and there is some volume available. So the matching can be done or not. Now the matching can be partial matching also. The matching can be complete matching also, full matching also, right? So it's just a feature that we need to decide whether partial matching is also acceptable or the full matching is the only option to go ahead, right? So those kind of caveats will be there. But this is more or less kind of idea of you know uh, buying and selling matching in a very easy way. I'm pretty sure that they will have very much more complex algorithm to actually do it in a different way or to make it much more optimized and user friendly. But this looks like a way to go, right? So you have any thoughts here to add?
Yeah, I think it looks good.
Yeah. So once the matching happens, then the order matcher also publishes an event saying that order matched, buyer details, seller details, buyer price, volume, seller price, volume, and everything, and which can be eventually uh, used by the reporting system. And definitely after the matching happens, as you said, the price ticker algorithm is invoked and the new price is generated and it is broadcasted or multicasted or whatever, right, to the other users, right? So that's how I think it can actually work. That's what I have in my mind. Yeah. So
So, how do we maintain the order? I mean, here. So,
order
uh,
what here? Yeah. Good question. So
order in terms
I
of
think
orders.
if you just see in terms of data structure, right, it is kind of a tree map, right, where it is already sorted, uh, by the price. So you can basically do a binary search. I mean, you can use the APIs, which essentially internally does binary search over the trees and goes to the nearest entry, and from there on you can actually start executing, right? So that invocation, ideally, if that invocation is O of one, that should be good. With binary search, you are probably getting logarithmic time, right? You're getting logarithmic time, right? With a balanced binary search tree implementation, something which happens in TreeMap, it will be much more efficient. But if there is some way to do it with O of one complexity, maybe we should actually do that, right? But that's the way of actually finding out the order, yeah, easily.
So basically, on the leaf, and I mean, on the leaf side, basically these nodes are connected. So there is sort of a linked list on the leaf side.
Yeah,
The leaf.
that also happens in something like I think B tree, B plus tree, those kind of things are there. But even if you don't do that, right? Even if you just use simple binary search tree, I mean balanced binary search tree, which is actually used like AVLT and all, which are essentially used in uh, uh, let's say tree map implementation in Java or equivalent. There also you can just go to the next entry basically, you know, in an iterator, or maybe next entry there is some API to actually figure out the next entry and go there. Or if you even can have the linked list in the leaf side, that may be used, or maybe something like linked hash map also can be probably used. Something similar to that, right? Where you can move from one node to another node, uh, right, after finding the first matching, right? So that's more of like a very low level details anyway. But definitely there are ways to
Yeah.
actually do this using balanced binary search tree or binary search tree, or even probably something like linked hash map. Yeah. So that's how probably
So
order
are we
matching.
going to maintain this data structure in the RAM of the server, or is
Yeah.
it something like I mean, we're not going to use any cache here, so yeah, I think it will be
No, let
basically
it
in the
be
RAM.
let it be in the in-memory of the server. Anyway, once if we lose this order matcher anyway, right? We can, let's say, bring up an instance of just a process, another process which will be eventually consuming from the same PubSub. I mean, from the same message queue, uh, right? And so we are not going to lose events, but I don't think so we need to put it outside of this machine. For latency, strict latency requirements, we can put it inside the machine only, the RAM only. That should be fine, right? Now let's say the order matcher crashes, right? And we have the in-memory pops up, which is in already in sequence. The only one thing is that don't you think so? There should be some level of TTL or some level of clearing from that pops up, right? Because once the data is consumed and there is no need of this data, right? Then the data has to be there might be can you
Not able to hear you.
yeah, can you hear me?
Yeah.
Yeah, I think there will be some level of housekeeping threads or housekeeping processes which will be probably clearing the pops up system, right? Uh, from the messages, right? So if the new order matcher comes up, it can basically uh, reread the messages, from the starting and can actually execute the order matching. But just one thing here, if we reread in case of order matcher, right? If we reread and if we execute the same thing, will there be problem of duplication somewhere?
Uh, you mean when we are keeping a copy of the whole system just for backup?
Yeah. I mean, let's say the order matcher crashed and our pops up system has some data, still some data, right?
Mhm.
And our order matcher comes and now has again started executing from the from the head basically or from the oldest entry, right? And there should be some way to for deduplication, right? There should be some way to know that this order has been processed or not, right? I mean, if a new order matcher instance or process comes up and it starts
Mhm.
processing the previous order again, uh, right? Uh, is there going to be some duplication?
Uh, so
First of all, is
I
the
think,
concern valid? The concern is valid, right?
yeah, so basically this whole system is just one server. So one possibility is that, the whole server goes down, then every process goes down. The other possibility is just one process goes down.
Hmm.
But how can one process go down? So it will go down only in the case of, let's say, uh,
It might go down because of, let's say, memory issues, something
yeah, yeah,
happened in that
out
particular
of
process.
memory issue or something like that. Yeah,
It can happen, right? Or
yeah.
yeah, uh, because we don't have
So
any way to know that till what actually the messages are actually processed, right? It's kind of again we are going back to kind of Kafka design only, but we don't want to do that here. But with our design, that problem is going to come here, right? That how do you know that exactly till what point we actually processed it? So we need to manage offsets or anything like that just to make sure that you don't end up with duplication. Or at least there has to be some
I think,
hash hash stored somewhere, right? That hey, we process this message or process this event, so you don't need to process it again.
so one thing is that every order should have a order ID, which can be, I would say, it's kind of auto incrementing. So that I mean, the newer order IDs are basically at least, bigger than the older order IDs.
True.
And so whenever the order ID is basically coming into order is coming into our system, we kind of punch it with a order ID. So we provide every order with the order ID. Then every order will also have a status. And when it's matched, basically it will have matched status. So what we can do is we need to our pub sub will have data, and that will we need to find the order which was last matched.
Yeah, I mean you need to
Or
find the offset, right? You need to find the position where which was perfectly
yeah.
matched, right? I'm told the order matcher crashed while processing some order at somewhere at some point in the middle, right?
Mhm.
Maybe there are other orders already waiting for this order matcher to work, to be acted upon. Right. But we need to know till what point the orders actually got processed. So maybe one option is that you save a pointer to that memory location or something like that to the disk itself. Right. That's one option.
I think we can do
Or
something similar to what Kafka does. So
hmm.
Kafka maintains an offset on its own end. Something similar can be done in our case, I think. So within the pub sub itself, I think we can store the latest order which was sent to the order matcher, and based on that, actually, we can just restart our
But
system in the order matcher process.
PubSub doesn't care about the order matcher, right? I
But
mean, even though I understand that.
we can store the order. I mean, last order ID which was sent to the pub sub. I mean, to the order matcher, not in the pub sub, maybe somewhere else. But yeah, we'll have to store it in somewhere in the
I
disk.
mean, I mean, in Kafka, Kafka knows which clients are connected, which consumers are connected to the system, right? So it can actually maintain a
Yeah.
book saying that, or record saying that, okay, fine, for this particular connection or for this particular client, this was the committed offset or this was the last offset. Uh, but here the PubSub doesn't care about it, right? So here probably the order matcher can store in on disk somewhere that, hey, this is the last timestamp, right? Or this is the
But
last order ID that we
you know,
processed with.
but I mean, why doesn't PubSub care about it? I mean, we can make it care about it, right? So
We can, but do you want to customize it for a single module or single
I mean,
process?
we are building the PubSub. I mean, we don't really have any other technology, right? I mean, which can basically serve all the purposes. So it will anyway be a customized technology, I would say. So we can customize it. If not customize it, I mean, my point is basically to have those functionality. If not in the PubSub, then maybe somewhere else. So what we essentially need to do is we basically need to sort
Yeah,
of keep an offset somewhere. If not in the PubSub, then maybe some other location, and then we can read that.
yeah, that's what I mean. Whether it is
Hmm.
done by PubSub or order matcher, some common location which can be read by the next order matcher, right?
Yeah.
To figure out that, hey, where do I actually start processing from? I mean, duplication and reporting system is probably still okay, depending on how critical that system, that use case is, right? Uh, Maybe, right? Or the reporting system can also create a hash. I mean, it can have some logic there. Okay, fine. Based on the hash, it will actually store in the reporting database or not. So it has some way to actually handle duplication. But the order matcher doesn't have any way. So yeah. So maybe there should be some common
Yeah.
location on the disk for storage, and that can be used.
I mean, duplication it will handle. There will be no duplication actually. The only problem is we should not be maybe sending the notification twice to the user. So let's say if we somehow when the server comes back or whatever, we match the order again, and for every order matching event we basically send a notification to the user. That won't be an ideal experience. So that is the I think that, and maybe some payment thing is the only thing that we need to consider. Apart from that, even if order matching happens twice, we are okay with that, because the system is
So
uh,
payment,
sort of
yeah. So
identical.
payment is not part of this flow anyway because the broker has already taken the payment, already taken the money. I don't know whether exchange actually manages in a wallet or not. I'm assuming that there is no wallet in the exchange for each user, right? But for each user, right, the clearing system will know that who is the broker and where to collect the fund from. So the clearing
Yeah.
system in the end of the day will settle it. So the payment doesn't even come here. So the payment that you do, you actually do to the broker only. It doesn't go to the actual seller or actual seller's account. Okay. So that is done by the clearing house later on as a part of settlement process, either T plus 1 day or T plus 2 day or whatever it is. So payment is fine. I don't think we are going to trigger any double payment here anyway. So that's not a problem. The only thing is, as you said, maybe notification, right? Or uh, maybe in some way doubling, telling the broker that, hey, this order has been executed and the broker has calculated double, right? That also can happen, right? because it matched double. Yeah. So I
Yeah, I
think,
mean,
yeah,
yeah, to fix that, I mean, we can just use the order ID as, idempotency key for the notification system. So we can sort of maintain a database on the notification side
yeah,
that these are the order IDs for which I have sent the notification. If the order ID comes, I, search that order ID in the system, in the database. That if it doesn't exist, then I send the notification, and else, I ignore it. So something like that can be done, which is basically very common. So
yeah,
yeah,
true. So the logic can be at the client side also, and maybe one backup logic can be there in the server side also, right? That
yeah.
that these orders are processed. But I think we want to keep the server side, more efficient. So we don't need to store all the orders that have been processed. Rather, the latest order ID should be fine, and the client can check that whether the data has already been received for this particular order or not. Yeah, the client can do the deduplication. Yeah.
So
Okay.
one question
Yeah. Yeah.
before we wrap up.
Yeah.
So, user makes a call to the broker to place an order. Broker
Mhm.
makes a call to stock exchange to place the order. Now,
Yeah.
order was sent to the order matching and all that. So, and then order was processed.
Mhm.
So, does the connection remain open all this while, or the stock exchange
Mm.
basically sends the response that order is processing or something like that, and then it somehow notifies the broker later when the order was actually matches. So that
I
part maybe we
think,
can discuss.
see, I think given the latency requirement, it has to be actually synchronous. I mean,
So
even though on Zerodha, right, you put some order,
yeah.
you immediately see if you don't have fund or anything, it got rejected. I mean, the matching doesn't happen. I mean, uh, the fund clearance and nothing happens, right? But the order matching happens. So even if the order matching failed for some reason, you get the message, right? So I think it happens synchronously. So now here
Okay.
the question is, how will it happen here, right? Because our gateway has taken the event, it is put in the pub sub, uh, right? And once the order matching happens, the event goes to the reporting system. So when do you reply to the user actually that this is the result of this match or of this call?
So I think what we can have is then I mean, we need to somehow tell the gateway that for this particular request ID, this is the response. Obviously, all the servers basically, I mean, as soon as the request enters the system, we basically punch it with the request ID. So that is basically that happens in all the servers. So I'm assuming that I mean that is something that will be happening at gateway. So at gateway, we basically provide the request with the request ID. Now,
See, the gateway also receives the message of order matching. When the order matcher puts the event for that particular order, the gateway also
yeah.
receives it. The point is that what act does it exhibit on that particular event,
Uh,
right?
so you mean gateway also listens to it? So yeah, I mean
Gateway sees the
then we
message, right?
also
Gateway also can receive the message because it's a PubSub system only. The only thing is whether it has to act on this or not, based
okay.
on the state, right, and based on the order ID.
Then I think what I mean, so the problem is order ID is being given later.
Mhm.
I mean, we can give the, yeah, actually we can give the order ID in the gateway itself. As soon as, order enters the system, we mark it with the order ID. It also has the request ID, and gateway will be basically listening to the pub sub. As soon as order status is marked to, matched, then gateway will basically know that, for this particular order ID, uh, the
But your
whole
gateway is
system, I mean,
becoming your gateway is kind of becoming a stateful system here because it has to match the result, right? I
so I
mean,
mean, in that sense, all the servers are anyway stateful. So I mean, even
no,
a
no, I
normal
mean,
server is
no, no, I
stateful in
mean,
that sense.
some connection is open on your server, and it is just waiting, uh, for some result. for some response, right, on that port
Yeah,
or
yeah,
on whatever,
yeah,
right? So it's just waiting for the result. But here it has to match the result. It works in the pretty much same way, but it has to wait for the order. It has to match it, and then it has to give back the result to the broker.
yeah. So for basically normal servers, uh, for example, I'll basically give an example. So those servers which have to render something,
Mm-hmm.
server rendered pages. For those, I mean, the companies usually keep a SLA of 200 milliseconds of overall latency. So
Mm-hmm.
uh, we basically expect that within 200 milliseconds, we will be, the whole request will be served with the rendering.
Mm-hmm.
So for 200 milliseconds, the request is waiting anyway in the queue. I mean, in the memory
Mm-hmm.
until everything is basically done. So it might have to call a third party, which let's say took 50 milliseconds because it had to call a database in the backend. So the request was waiting anyway. I mean, at the server. So in that
Mm-hmm.
case, in this case, what is happening is the whole thing is basically complete in 20 seconds or let's say 30 seconds. So sorry,
Milliseconds.
milliseconds, 20 milliseconds. So
Yeah.
I mean, it's essentially the same thing basically. So I mean, to an outsider, there won't be any difference. So it will feel like the request was executed immediately.
Yeah.
Internally, it looks different. I mean, it's not a request response like in the usual servers.
So
But
so
yeah,
it has to maximum wait for 20 milliseconds in our use case. Let's so
yeah,
whatever is the threshold that we decide. Within this time, if it doesn't get a response, then it has to say something, some error, right? But
yeah,
given
yeah,
that the system is whole placed in a single machine, so most likely it is going to get a result and going to give it back.
yeah,
Going to write a response to the port that hey, I'm done. Yeah. So something basically has to be implemented internally to listen to that message for that particular order and accordingly construct the message or timeout. Right.
yeah.
Okay. Okay. Anything else, man? I mean, we're already 2 hours. This is too long, man. Too long and too late. Okay. Anything else, Karthik, you have in mind?
No, I think let's wrap it up. I think we have covered a lot of things.
Okay. I'd like to see some response from the viewers also. So I hope they don't get scared seeing 2 hours long video, but it's full of information and full of very candid discussion, right? Uh, like engineers, as good engineers would like to do. So I'll be waiting for the response. Yeah. So I'm stopping the recording and yeah, good luck.